Hello everyone, welcome once again. We are in the improve phase and we are talking about generating the solutions, prioritizing those solutions and assessing the risk. That's what we have done so far. As part of the improve phase, idea is to build the solutions and validate them. So we are in the validation stage right now. We have already built the solutions and designed them using the methods like brainstorming, standardization, mistake proofing, 5S, and Edward de Bono's 6 thinking hats. So, and then we prioritize them using urgent, important metrics, and then we also try to assess the risk in our new solutions using the failure mode and effect analysis. So we have developed solutions, we assess the risk also. Should we implement them right away? Maybe not. We'll say hold on, we have to take a structured approach. We have to implement our solutions on a small scale in a very controlled environment where we can see that if they are working well or not. Should not be any issues also in the process. That's what we have to first look at. So for that we choose a methodology called as piloting the solution. So if you can see my screen, we talk about piloting of solutions. In the next screen that you can see, we're talking about conducting a pilot. So conducting a pilot typically goes on a typical project management methodology called plan, do, check it. That's the methodology we use here. In the next slide, we'll talk about why do we need a pilot. Now, it says that to better understand the impact and obtain feedback from, we need to do a pilot because we want to understand how the process might function in a bigger scenario. We don't know, so why to launch it in a bigger scenario and then face backlash and then try to change it. So let's try to put it in a control environment. So we are looking at feedback and impact understanding from customer, from vendor and supplier, from process and workers, from internal technology or existing system. That's why we are doing a pilot testing here. And why are we doing it? Because we want to reduce risk of failures by identifying areas of potential failure. So in the case of Flipkart, they could have chosen a group of people and they could have launched their initiative, and they could have seen if the payment gateway, merchant gateway, website, everything is working well or not, and then they could have launched their initiative of Big Billion Day there. Similarly, whenever a company is launching a new initiative, they always conduct a test in a control environment before they launch it. For example, a car. So car always goes through a lot of tests, a lot of quality test, even the crash test also before they launch it for the end customer, because they want to see how will a car perform in that condition. They want to see how the car suspension, what will be the mileage of car, the AC, how will the car perform in different terrains and different kind of city condition or highway conditions. Can it withhold the impact? For that they do a crash test also. So that's why they need to know all these details right now before they launch a car and they send it to the business in the real world, and people start facing issues and the accident might happen. That can be a loss of human life. That's a big thing. They cannot afford it simply like that. That's why we need to understand it now, what could be potential failure modes. And it helps to increase buy-in. If we are already aware, if we have done a pilot testing, we can be confident about our own product. It validates and refine cost, the benefit cost and benefit estimates. We can get it, perform the adjustments. If there are any changes that we have to do it now, we can do it now. You would have read a lot about it. Companies recall sort of cars from the market. So imagine thousands or millions of cars are being recalled from the market. It's a cost for the company because they are correcting that failure in their cars free of cost, and that's a huge cost for the company. Now it's in the real world it is happening. Had they tested this thing earlier, they could have identified it before. It could have saved a lot of cost for them. And the customer who had purchased the car also loses some confidence in that product and in that brand. So it's not really good for the reputation of an organization. It's a cost issue, it's a reputation issue, it's a future revenue and the profit issue. So pilot testing is very important in that case. Of course, sometimes it might shut the entire business, and it evaluates the effectiveness of measures used to monitor the improvement, and it tests the validity of the solutions. In the next slide, we try to understand when should we pilot a process. The slide says factors we need to consider when should we pilot a process. when the cost is high or resources are currently unavailable. When the cost of a solution is very high, you have used millions, sometimes billions to prepare a product, it is better you test it before you send it into market and it crashes. The cost is very high. The resources who worked on it, they may not be available on it again. So it's better you test it. Now, for example, the astronauts, when they go out in space, they go through multiple tests. They launch that satellite under various circumstances, before they do a final launch, because those astronauts will not be available if something goes wrong. So the cost of launching a satellite is also very, very high. So before satellite is launched, they go through months of training and months of testing that happens in different temperatures, different conditions, and they also go through and they do a detailed FMEA also in that scenario. The next point talks about credibility for the design. Design needs to be established. When you want to gain the confidence that the product which has been designed, it is really foolproof, it really works well. So that credibility can only be there when we have tested it into certain conditions and we have overcome all the issues in that. When it is difficult to reverse solution, consequences and the results. So when sometime the consequences or the results of a problem in a product or a process, when it cannot be reversed back. For example, we make a medicine or a food, and if somebody eats it, has a food poisoning, or they die out of it, or the medicine, there can be side effects. People can sue the company and they earn millions out of it, or somebody lose lives. That's a big issue for an organization, for a medical company or for a food company. They don't want that risk, so they will test that food or the medicine under various controlled conditions to ensure, because that result, somebody is losing life or somebody is being disabled, that cannot be reversed. So they don't want this to happen. It's a big brand damage, revenue damage, goodwill damage. So they don't want it. That's why the piloting is very important there. When the potential far-reaching and or unintended consequences, very much similar to what we just talked about. Scope of the design is complex or large. When we have developed a product which is very complex in nature, or it's a huge design, and obviously again the same thing comes in, because if you put it into the real world, if something happens, then you can't change it again because the cost is very high, or it's very complex. You can't again go back and try to change it. So better you do anything, fix it here, look at it here, rather than change in the real world. Substantial training required. When a product or a process requires a lot of training, then it definitely needs to be tested now. All training needs to be given, then you can finally launch it for the people to go through it. Training and substantial changes to job design. When you launch a process in the real world and it changes, and the training it changes the job design itself, that's when it is important that we need to pilot solution here. For example, computers. When computers came in the real world, it actually changed this entire thing. The job description changed for people. How do you have to work on a computer? So the job description changed, job design changed. So before you launch a computer, you have to train the people. So this last point is absolutely about when you introduce a new technology for people. Anything which was manual, now it is replaced with a computer. So the training and substantial changes to job design, if it leads to training or a job design changes, is definitely testing has to be done, that what training and job design people may go through. So let's test it now. And there are certain elements of a pilot plan that we must always remember. These elements are a contingency plan, pilot success criteria, potential problem analysis, scope of the pilot, training plan for the pilot, communication for the pilot, data collection, schedule and the work plan of the pilot, and verification plan for the pilot that needs to be taken care. So these are 9 elements of any pilot that we are doing. Pilot should not be a hush kind of thing that we have to simply do it. Okay, let's find a team, let's implement solution there, let's see how it functions. In a pilot, you do exactly same you do for a full-fledged solution, wherein you prepare the entire documentation as it is, detailed one same document. You train the team in the same manner. You communicate to all the stakeholders in the same manner. The same amount of cost which you invest in it, the same kind of seriousness you have to put in. People are trained in that same manner. and we need to find the scope in the right manner, like what would be the right scope of the people where need to implement that pilot. And pilot success criteria again has to be defined very well. What will be the condition? When can I say my pilot has succeeded? When can I say my pilot has given me intended results? That's criteria has to be defined well. And if my pilot fails, what is my contingency plan? Pilot fail does not mean you go back and try to change the design and everything again. What would be your plan B? That contingency plan again has to be planned well. Data collection from the pilot is very important because that will help us to get to us the right feedback that we may need in order to change any part of the pilot or change the solution or the design. So data collection becomes very, very important and critical here. Then schedule and work plan. How, when, and where we are going to run a pilot. Pilot can go on from few hours to few days to few weeks to few months, sometimes few years also when it comes to the pilot. Maybe not too long it should be, and sometimes we have to stop it. And then verification plan. At the end we try to verify has the pilot been succeeded or not. So this entire process, these all elements should be part of the pilot. Pilot should be taken as serious as a real world implementation of a solution takes place. That's about piloting. In the next session of the pilot plan, we'll continue with pilot plan. We'll talk about how to actually execute a pilot, and we'll talk about and what is the next steps once we have concluded or executed a pilot. Thank you for watching. This is Shivendra Sharma.